So light has always been a driver of progress, from discovery to productivity and safety. The last revolution made light more efficient. What we're going to talk about next is kind of what opportunities exist to reach those that are still without light and power. So John Bowers, who's sitting closest to me, is the founder of Unite to Light. He's also the Fred Kavli Distinguished Professor Emeritus from UC Santa Barbara and a member of the National Academy of Engineering. Dr. Bowers is a world-renowned pioneer in silicon photonics, the technology helping move data faster and more efficiently through the internet, AI systems, and future communication networks. His groundbreaking work in lasers and optical networks has also shaped the future of energy-efficient computing and communication. Thank you, John. Joining us is Dr. Stephen DenBaars. He is the can't say that word this morning. We're without coffee, so I think that's why. Mitsubishi Distinguished Professor at UC Santa Barbara and Director of Institute for Energy Efficiency, where we're sitting today. Dr. DenBaars is internationally recognized for his pioneer work in LED lighting and gallium nitride semiconductors. He's going to have to tell us a little bit more about that. Innovations that power the bright, energy-efficient lighting and display technologies that we use every day, from smartphones to large-scale displays and modern LED. So together, their work has really transformed how we use light and energy. Please join me in welcoming Dr. Bowers and DenBaars. So you've both helped shape the LED lighting revolution. What impact from the transformations are you most proud of?
Go ahead. Want to go? Okay. I think the thing I'm most proud of is that UC Santa Barbara really became the center for LED lighting research in the United States, if not the world. That started with not only John bringing me here in 1991, a long time ago, to work on this material, but also then I brought over Suji Nakamura in 2000. And when he came over, it wasn't obvious that LED lighting was going to replace lighting. And what I'm most proud of is that we increased the efficiency of LEDs from the time he came, which was about 5%. We've now increased it to 80%. So that's 80% energy efficiency. Your regular light bulb at home is 3%. So you could see that using 80% of the energy for light is much better than using these hot incandescent light bulbs. And the California Energy Commissioner just told me some hot news, which was that I think he said 6.7 billion is the annual savings in California, just the state of California, for energy efficiency. So I was really excited because I've been telling people those kind of projections for a long time. So that's what I'm most proud of, is that we took something that looked like it was going to work and we actually got it out into the commercialization and helped several companies do that. So, and then of course I'm happy to help Unite to Light, and I was happy to help John, get the LED lighting, but it was really his idea for how to get LED lighting to the masses. So why don't you tell us about that?
I think the part I'm most proud of that Unite to Light has done is indeed the 280,000 lights, and we now have probably 25,000 students, that data on it, that the graduation rates go up 30%. And so, in today's era, it really is a shame that people don't graduate from high school. And I think students are motivated, they're smart, but if they go to bed when it gets dark, then it's a really lost opportunity and lost generation. So I think, indeed, we'd have to do a lot better and get a lot more lights and electricity. And we all know, energy is GDP, right? And to get the economy going, you need energy. And with a kilowatt per square meter that the sun gives us, it's just stupid that we still burn kerosene or candles or wood, which obviously has health impact. So I'm proud of what we've done, but yeah, it's just a drop in the bucket.
And the need for solar lighting has dropped drastically. When Unite to Light started making lights, and I was talking to Anna from Snyder Electric, they've been doing about the same amount of time. People without electricity was 1.5 billion. We're down to about 700 million, so we've halved that in the last 16 years, which is fantastic. But the Global Off-Grid Lighting Alliance, or GOGLA, either way, it's a mouthful, they report that about 250 million people are still being left behind. So 250 million people are still being left behind. So we are absolutely here today to celebrate the work that we have done, because we have made so much progress, a lot on the technology side from these two gentlemen. And it's going to be exciting to see how we help the next set of people. So I guess I just kind of mentioned that. Where did the first lighting revolution fall short in reaching global populations?
So I think where it's fallen short is you still see a lot of incandescent lights and a lot of kerosene and other forms of lighting being used in the developing world. So while the costs have come down, I think we still haven't put in the infrastructure of solar power plus LED lighting to get it to the masses that are missing it. That's the main thing we needed to do better on, reducing the cost enough to make it affordable for everybody. We've tried to find dual-use technologies that make it more accessible. For instance, trying to put information on the light as well, so you can do Li-Fi. You don't need a Wi-Fi router. You just use that to transmit information at the same time you do light. So, working with, I think, also local industries, which, United Light has done, has helped. You just half that number, which was impressive. I didn't know that. So that's going a long way.
And when we were talking last, you mentioned something really interesting I wanted to bring here. How does lighting evolve in the in health technology?
Oh, okay. That's something that we're working on currently. So you all know we can make blue and white lighting. What we probably don't know is we can actually make ultraviolet lighting as well. And so there's been a real push lately. It started with the COVID, where some of our member companies, like Seoul Semiconductor, pioneered UV LEDs, and we've worked with them. So if we can make UV LEDs as efficient as we did with LED lighting, then we can use it for mass disinfection of surfaces. It started getting deployed a lot during COVID because you can put your cell phone in these little UV boxes, LED boxes. Those could be solar powered as well, so you don't need to be connected to electricity. But we still need to work on increasing the efficiency of the UV light so that we can put it in air systems. It's not as efficient yet as it needs to be to do what I'd call water for purification, for instance. So that's something that one of my students really said. That I think just last week he said, "This is my project. I want to work on UV lighting for health and do something that impacts the world." So that's something we continue to work on.
And what role does spectral engineering play in human health and performance? You might have to describe what that means for us all.
Okay. Spectral engineering is changing the color of lighting, but and maybe you do know that when you travel internationally, your body clock goes off. That's called the circadian rhythm, and that's actually set by light. And so one thing we've been doing is developing lights that help you recover from jet lag faster. That's one area we can do spectral engineering. And so, you should all go outside when you get to the country you're at just to reset but also at night, you should probably start dimming the blue on your cell phone screens. And all those of you that are reading your iPad in bed after 9 o'clock, that's a no-no. You shouldn't do that. You're spectrally engineering your brain to stay awake. And so that's what I mean by spectral engineering. But we can also put in wavelengths into light that make it healthier. So we can put in a certain wavelength in the UV that generates vitamin D. So sunlight generates vitamin D. So we can actually now make light bulbs that, in addition to wake you up, hopefully, rather than take a pill of vitamin D, you just have the light bulb on for a certain amount of time. Those are some of the things you just, if you want to wake up in the morning, just turn on your computer screen full brightness for 15 minutes, and that'll help.
So no coffee needed.
No.
So let's get back to kind of thinking globally. John, what system-level innovations do you think are needed to scale off-grid lighting globally?
I mean, today, the lights we make are already cheaper than kerosene, right? But we're not displacing kerosene to a large amount because, there's upfront cost of buying the light. And that was actually how we originally got started. The cost of solar-powered lighting was more than the annual salary of a person in Ghana, and that's how we got started. So certainly microfinance. We certainly need to get distribution centers in Africa. I think United Light needs better partnership. So Solar Sisters is here, and they've been fabulous for the last 10 years in a couple of countries. We'd love to see Solar Sisters get a lot bigger and replicate other organizations in other countries. But we need partners to do distribution. Direct Relief has been phenomenal for us as well. So to me, it's about distribution. And obviously, the more we manufacture, the cheaper it gets. And so we're just still moving down that curve. But people shouldn't burn kerosene. And obviously, the whole carbon offset, that should fully fund solar powered lighting in Africa. So I hope more companies get involved in using carbon offsets this way.
Let's stay on that. Let's stay on that vein. So the people you have in this room, we've got some academics, we've got some policy people, we've got nonprofits, we've got financiers, we've got technology people, we've got just wonderful cross section. And I'm so excited everybody's here because often we exist in our silos. But we're here today and we're here to have this conversation. So I'm going to pose this to both of you. You know, what opportunities exist staying on that line to ensure that, you know, this next lighting revolution really does reach everyone across the globe?
Wow, that's a tough question. I think it's like you said, John, we need to reach out to the nonprofits and carbon capture community. I don't think we have much representation in the UN. I had only one student in 30 years go into policy at the State Department. After 20 years there, he then formed a lighting company in San Francisco, which then got acquired, and then he retired and he donates it to us. But you know, he just said it's so hard to change policy. We can all change science, but policy is, I think, thing holding back widespread deployment in all the countries you go to. I mean, it's just getting the right people aware of the technology that it could really help the infrastructure there.
But as you know, 10 years ago, lighting was way too expensive. And fortunately, California, I think, took the lead in terms of banning the incandescent light bulb. And that really forced high volumes of LEDs and took it down that cost curve, and now it's obviously cheaper than, or at least
yeah, that's a good point. If I had to look at one moment in history that all the LED companies grasped onto, is when California, it was literally banned a light bulb. It was a policy move, banned a light bulb. Now it got some other people really mad that they tried to get around it a couple years ago, and unbanned a light bulb. But it didn't matter because by the time, you know, LED lighting had rolled out, and this ban to light bulb was then picked up by several states, but other countries like Japan, which wasn't leading at the time, grabbed onto that. My friends in Korea saw that policy change and took it to their politicians. So it's funny how these policy, to me, is, I'm not a politician, but policy really does impact, I think, the last mile that we're going to have to do.
So I think we're all disappointed in the rollbacks that are happening in the last couple of years, the last year in particular, for whether it's car standards or efficiency standards. But I think we certainly could do something with lighting and kerosene. I don't think you can just go to Africa and ban kerosene, because unless you have an economic alternative that works. But that could have a big impact.
I think we've got just a couple minutes. Does anybody have a question for Dr. Bowers or Dr. DenBaars? Any parting thoughts?
I want to highlight one thing that Steve in particular works on, but we do a lot of work on lasers. So everybody talks about LEDs, and Steve knows I've always been a laser guy, so I always keep waiting for this. But they've very strong effort here in gallium nitride lasers, and lasers have a much higher intensity and take a lot less area to get large amounts of power. So if you really want 10 watts, 100 watts, you probably want, to me, a laser, and it's more cost effective, because in the end the area you take up in the wafer is what the cost fundamentally is. So I think there's more revolutions in the future, and that would be one.
I didn't even mention it, laser lighting. And this projector here, unfortunately, is not a laser projector, but we could replace that light bulb with and they're very small. You can buy laser projectors today, and some of them are used in the Sphere in Las Vegas for projection.
And what's another application for that?
So street lighting. You can light about 1 kilometer of a street. You don't need street lights spaced every 100 meters. So laser street lighting can do about 1 kilometer.
I think you could use it even for household, right? I mean, as long as you disperse it.
Yeah. Fiber optic. If we had one laser system, it could probably do the whole house or even a building someday. But yeah, these are the things we work on with John's help as well. And then the last thing I want to mention is, it's not just, since we're international, but John's working on lasers for increasing the efficiency of data centers. And it really looks like both LEDs and lasers are going to drastically, what we did for LED lighting, we can do to help reduce the energy consumption of data centers, which is kind of the next big challenge that we're facing here in California, is these things are just consuming huge amounts of energy, and it will equal the amount of energy that goes into lighting in about 3 to 4 years. So we're not talking about a small amount here. So that's my parting thought.
All right. Thank you both so much for the work that you've done and for being here today. Really appreciate it.